Hi guys. So today what I want you to do is I want you to take out graphing trig functions number 4, okay? And then what I want you to do is I want you to graph y equals cosine x, and then y equals cotangent x, and y equals secant x using that unit circle, right? And the coordinates on the positive x-axis, the positive y-axis, the negative x-axis, and the negative y-axis, and then back to the positive x-axis. Okay, so go ahead and do that and pause the video, and when we come back, I'll show you the answers to these, okay? Okay, so this is what you should have gotten. Cosine, the period, how long it takes to repeat is 2 pi, so 0 to 2 pi. It starts at a 1 right here at 1 on the y-axis and then comes down to pi over 2 on the x-axis and then down to -1 at pi and then back up, okay? All right, and then cotangent x, okay? It has vertical asymptotes at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. Negative pi, -2, -3 pi, and y. Okay, so why is it going down? Okay, because right here between 0 and pi over 2, that angle is in the first quadrant, and x, y, and r are all positive in that quadrant. So when you do the ratio for cotangent of the x coordinate over the y coordinate of that point that's moving on the circle, that ratio has to be positive, okay? So this part of the graph has to be above, and we have to be approaching this vertical asymptote. So that's why it has to be approaching this way, okay, and decreasing, okay? From pi over 2 to pi, that angle describes the second quadrant, the upper left quadrant, and in that quadrant, the x is negative, the y is positive, so when you do the ratio of x over y, you're going to get a negative ratio, and that's why this part of the graph is below the x-axis, and it has to have that asymptotic behavior because we have a vertical asymptote at pi. And you could go across and it just repeats. The angle between pi and 3 pi over 2, that's the third quadrant bottom, or the bottom left quadrant, and x and y are both negative there, so when you do the ratio, it becomes positive. That's why this part is above, okay? And then at every odd pi over 2, okay, positive or negative odd pi over 2, what happens is you get 0 there, because at pi over 2, that is on the positive or the negative y-axis, and if you do the ratio of y over x there, okay, or sorry, x over y, you're going to get 0 over the y coordinate, which would give you 0, and that's why these are all x-intercepts, okay? All right, and then secant x. Secant is the reciprocal of cosine. So cosine is x over r, so this one's r over x, okay? So that's the ratio, okay? So for angle 0, okay, when you do the ratio of r over x, at angle 0, the x coordinate is 1, and the y coordinate is 0, and r is 1. So when you do 1 over 1, it's going to give you a ratio of 1. That's 1 right there, okay? And then at pi over 2, when you do the ratio of r over x, at pi over 2, x is 0. So when you do r over x, that's going to be undefined. That's why you have this vertical asymptote right there, okay? And again, between 0 and pi over 2, that's the first quadrant right here, right? And if that's the first quadrant, the entire graph has to be above the x-axis because the ratio is positive in the first quadrant for r over x, okay? Actually, in the first quadrant, all the ratios are positive, right? Okay, because x, y, and r are all positive, okay? All right, and that kind of describes it. So this one has this point right here at 0, 1, and then at pi -1, and 2 pi 1, and 3 pi -1, okay? And your graph should look like this, okay? Let's go to the lesson today, all right? So today we're going to be constructing a sinusoid. They're actually called sinusoidal functions because sine and cosine are both called sinusoidals curves. But I want to construct a sine curve. So I'm being specific this time. I want it to be sine. We've been modeling with cosine, but this time I want it to be sine. And I want it to have an amplitude of 4 and then a period of 3 pi over 8. And then I also want it to pass through the point 5, 0. Okay, so let's do one thing at a time. So we're going to start with y equals sine x. Okay, and what I want to do is I want to give that an amplitude of 4. So I want to vertically stretch it by a factor of 4 is basically what that says. So that means the amplitude is right out here in front of sine. We've learned that from previous lessons. So this is going to be y is equal to 4 sine of x. Okay, so that will just have an amplitude of 4. That'll be the sine curve with an amplitude of 4. Okay, Now we want to have a period of 3 pi over 8, okay? That means I got to figure out my b value that will cause this to happen, okay? So what I'm going to do is I'm going to take 3 pi over 8, which is my period, and I know I can get that by taking 2 pi and multiplying it by 1 over b. So 1 over b is times 2 pi would have to give me this 3 pi over 8, okay? All right, so now what we can do is multiply both sides by 8b to clear out our fractions. So I'm going to do that to both sides. Okay, so when I multiply this, my 8s are going to cancel, and I'm going to be left with 3 pi b is equal to, okay, so here my b's are going to cancel, okay, and I'd be left with 8 times 2 pi, which is 16 pi. And then I'm going to divide both sides by 3 pi, and so b is 16 pi over 3 pi, but the pi's can cancel here, and you're left with b is equal to 16 thirds, okay? All right, so my b is 16 thirds. That's the thing I'm multiplying x by. Okay, so now this is going to be y is equal to 4 sine of 16 thirds times my x. Okay, so now what this function right here will do is it will produce a sine curve because it's sine, all right? And it will have an amplitude of 4, and b being 16 thirds will cause it to have a period of 3 pi over 8. Okay, we took care of the reciprocal part right here by multiplying by 1 over b, okay? So if we multiply 2 pi by 3 over 16, because our b is 16 thirds, so the reciprocal of 16 thirds would be 3 over 16. So if we take 3 over 16 and multiply it by 2 pi, we will get 3 pi over 8 for the period, okay? All right, so remember this number right here, we're always multiplying by the reciprocal of that, okay? All right. Okay, so then the last thing we want to do is we want it to go through the 0.50. Right now, it's going through the 0.00 because we haven't moved it left or right or up and down, and the regular sine function, right, goes through 0, 0. Okay, remember that's one of our key points for sine. It's that's the first of the 5-point method. Okay, so if we have this, right, and we have sine, this is going to look something like this, right? And this point right here at 0, 0, and I want to move it to 5, 0, I could just shift this over to the right 5. Well, how do I shift to the right 5 or translate right 5? I need to take 5 away from the x here, from the x, not from 16 thirds x, but just from x. So then that would become y is equal to 4 sine of 16 thirds times, and then we have to open a parentheses, and then x minus 5. Close the parenthesis, close the parenthesis. Okay, so this is going to cause, the 4 is going to cause an amplitude of 4. The 16 thirds will cause the function to have a period of 3 pi over 8, and the x minus 5 will cause it to shift right 5 and go through that point right there, okay? All right, sine, if you're given like directions like this on how to create a sine function, and you're given this point right here, okay, it's easy to move the sine curve and translate it to get through that specific point that you want, okay? Because the sine curve starts at 0, 0. So this would be harder to do with cosine, okay? Because cosine starts at 1, 0. So we'd have to actually move it down and to the right. We'd have to move it down 1 and right 5 just to go through the 0.50, okay? And it would have all these things, okay? All right, so one more thing I wanna show you before I go to the next example is how do we, sometimes these won't be given to us in this format, right? In transformation form, and I'm gonna have to pull the 16 thirds out, okay? So let me scoot down a little bit, and we're gonna add one more little example here. Okay, so we want functions to look like this, these trig functions. Y is equal to A, and then sine, this could be sine or cosine, okay, and then parenthesis, and then B, and then parenthesis, and then X minus, or it could be plus C, close the parenthesis, and then plus d. This is transformational form. Okay, because we can tell the vertical stretch or compression, we can tell the horizontal stretch or compression, and the C, depending if it's positive or negative, we can see if it translates it to the left or to the right, and then the plus D is the translation up or down. Okay. All right, so this is called transformational form. So it's not always given to us in this format, okay? We need to be able to look at these trig functions and go, oh, that's the A, that's the B, that's the C, and that's the D, okay? All right, so something like this. Let's write y is equal to 3 sine of 2x minus pi over 3, okay? And then let's say plus 4. Okay, so here's the problem here. All right, I don't have this. I can see the A. The A is 3, and I can see the D. The D is 4, and I actually can see the B, but it's not in this form. What I can't see is C right now. Okay, so what I can do is I need out of these two terms. Notice B has been pulled out. Right, we're multiplying x minus C by the B. We need to get this x by itself. We need to be taking x and either adding or subtracting from it, okay, or to it. So what we need to do is from these two terms only right here, we need to factor out a 2, but there's no 2 to factor out here, okay? So there's a way to get a 2 here that we can factor out, and it's multiplying by 1, okay? So we would rewrite this as y is equal to 3 sine of 2x minus, and what I'm going to do is I'm going to multiply by 2 over 2. Now, why 2 over 2? Because that's 1. Okay, let me finish writing this and I'll say some more. Okay, this is 1. So this is still pi over 3. But this 2 in the numerator, I can factor it out now. I can pull it out with this 2, okay? All right, so this becomes y is equal to 3 sine of 2 parenthesis, and then it becomes x minus, and this would become this 2 right here got pulled out, right? So what I'm left with is 1 over 2 times pi over 3, and that would give you pi over 6. And then plus 4. Okay, so earlier we could see the B, right? It was 2, all right? But what we couldn't see is the C, right? So what this is this sine curve has an amplitude of 3. It has a B value of 2. So to get the period, we take the reciprocal of that, 2, which is 1/2, and multiply it by 2 pi. That would give us a new period, okay? And then we can see that this has been shifted to the right, pi over 6. So up here, it looks like it got shifted pi over 3. It didn't. It got shifted pi over 6 because this is double the x, right? Okay, so we need to get the x all by itself like this. So x minus something or x plus something. And once we do that, then we can tell what the shift left or right is, okay? And it's still a shift up 4, okay? All right, so you need to be able to do this. We're going to do this in the next example, okay? And I'll show you that one, okay? So let's go to that. Okay, so this function, we have y equals 5 sine times, and then 3x minus pi over 7, and then minus 4. And I want to be able to state the amplitude, the period of the sinusoidal, okay, or the sinusoid, and relative to the basic function, right? The phase shift and the vertical translation, okay, or vertical shift. We also call this vertical shift, okay? All right, so let's get this into the transformational form so we can pull all of this out, okay? All right, so what happens is we can see the B, but we can't right now see what the C is, what the C value is, okay? So I need to factor a 3 out of both these, okay? Because I'm multiplying x by 3, okay? So I'm just gonna off to the side here write equals, okay? And this would be 5 sine of 3x minus, and what we can do is multiply by 3 over 3. Okay, so I'm going to take the minus and then subtract 3 over 3 times pi over 7. Close the parenthesis and then minus 4. Okay, so then what we can do next is, I'll just come down here. okay, is we can now, this allows us to factor a 3 out. Okay, so this would be 5 sine of 3 parenthesis, and then x minus, okay, so this top 3 got factored out. So we're left with pi over 21. And then close the parenthesis, and then minus 4. Okay, now we can read everything off this. Okay, so for the amplitude, is 5, right? Okay, so that's the first question. What's the state the amplitude? Amplitude is 5. That's that number right there, okay? It's actually the absolute value of it, right? But since it's positive, it's just going to be 5, okay? Now, the period of this, okay? Now, our B value is 3, right? So our period will equal 1/3 times the normal period, which is 2 pi. That's the normal horizontal distance for my x's for the basic function, right? So I know that this is going to be a horizontal compression by a factor of 1/3. So that means that normal period of 2 pi is going to get compressed by 1/3. That's why the 1/3 right here, okay? So 1/3 times 2 pi is 2 pi over 3. Okay, so this curve is going to repeat every 2 pi over 3 units, okay? And then we did the amplitude, we did the period, the phase shift. So this got shifted to the right, pi over 21, okay? So the phase shift is right, pi over 21, okay? And then the vertical translation is down 4, okay? So vertical, we can say, I'll just say vertical shift. And it would be down 4, okay? And these are the 4 things I asked you to find, okay? Now, again, today, some of the questions are gonna stretch you in your understanding of this. It uses everything I taught you, okay? But you have to take what I taught you and apply it to like a graph from a graphing calculator, and then tell me like the window settings, because you can count the periods, all right, and know what the x max or the x min or the y min or the y max by just knowing, by giving you this function, what the amplitude is and then what the period is. You can figure these things out, okay, from a grid, from the graphing calculator screen, okay? And that's what I want you to kind of figure out. It's more problem solving using what I've taught you, okay, and figuring things out, okay? All right, guys, that's it for today. Have a great day. Hang in there. Keep doing the work. Keep doing the work. I want to encourage you, okay? You guys have done a wonderful job. I am actually really pleased with where you guys have come, okay, and what you guys are doing, okay? A lot of you guys are doing the work and you're putting in the time. And like I said in that email, it's an investment, okay? You're investing in the future grades in math classes by doing the work right now. It's just an investment. You got to not think of it as a paycheck. You got to think of it as an investment. Like, I'm putting this away for a rainy day, okay? And it will pay off, okay? Trust me, it will pay off. It'll make things easier next year, okay? All right, you guys have an absolutely wonderful day today, and you guys take care. See ya.